we put, well, maybe it's easier to do it like that. So we have triangle ABC, ABC. So then this is an angle bisector. Right, so that's the angle bisector of the interior angle, angle ACB, and we'll have an angle bisector of the exterior angle. Well, it's kind of like they meet very far away. Maybe it's easier to just change this because I don't have such a long board, right?
I just made my thing like curved too.
See if that's, yeah, it's kind of, it's easier to draw that. So make it like that. That's like right there. I'll cheat a little bit so that actually they meet. Okay, so it's still A, it's B, so this point is F, and then we take, this point is D, so we draw a line that is parallel to BC, and it intersects AC at point R. That's R, right? And then we connect F and R. And here's a point. So we're trying to prove that N is the midpoint of BC, right? So there's a hint, right? They ask you to produce dr to meet CF at S. So then you just do that. Okay. That makes it easier. So I mentioned last time, whenever you have the situation like this, there's a triangle, and this angle bisector of the interior angle, the angle bisector of the exterior angle, you always know that this is 90 degrees. Right? So that we got 90 degrees here. Right? Let's label this one is angle 1. This one is angle 2. And this one is angle 3. So, what can we see from here?
2 equals 3.
Yes,
2
2 equals 3, right? That's given.
Also
And 2 equals 1. So, that's helpful. Well, the proof goes, well, first of all, we, this is given. Right, that's given. And because RD is parallel to BC, this tells us that angle 2 equals angle 1. Right? Whenever two lines are parallel, the alternate angles are equal. Right? So that from here, we get angle 3 equals angle 1. Right? So that this side equals that side. So from there, we get RD equals RC. Because this is an isosceles triangle. Right? So from here, can you see that RS equals RD?
No.
Yeah?
Yeah.
Why?
Because
Is it-
SCR is 90 minus 3, and angle R is, that's like no, that's 2, 3. So then they're equal, because the angles are equal.
The angle SCR, SED, I mean, is 90 degrees. That makes, like,
Yes,
that makes angle S, like,
This angle.
CSD, that angle,
Uh-huh.
minus the CDS
CDS,
is equal to angle SCR minus angle
SCR
angle DCR. That makes
minus
it,
DCR.
so that just makes it isosceles triangle.
I don't get it, did you get it?
I don't-
Like, angle CRD is equal to 180 minus 2, 3.
Yes.
So then the alternate is just equal to 2 times angle 3, right? And one
So
of
this
them,
is 2 times angle 3, right?
yeah, one of them is
So this
90,
is 2 times angle 3, let's say, put it here.
One of them is 90 minus, and then what you just subtract that from 180, right? And then you have one of them is okay, if you take 180 minus 2 times angle 3 minus 90 minus 3, you end up with 90 minus 3. So those
I got lost.
Um,
Did you just
just
write it?
label it.
That's 2 times. Well, let's say this is 4. This is 5, right? And because this is the right triangle, then we have angle 1 plus angle 4 equals 90 degrees. That's obvious, right? And because this is 90 degrees, so that angle 3 plus angle 5 is also 90 degrees. And because we have angle 1 equals to angle 3, these two angles are equal, right? So that these two will also have to be equal. So that we get angle 4 equals angle 5. Okay? So that means SR equals RC. SR equals RC. Right? And then because RC is also equal to RD, so that SR equals RD. Yeah. SR equals RD. That means R is the midpoint of SD. Right? So that's the configuration when you have a triangle. Right? And then you got a line that's parallel to the base.
Yeah.
You draw any line,
And then the
so that the ratio
ratios is the same.
of this to that is always equal to the ratio of this to that, right? So if you take that point, the ratio of this over
Oh, I got
this
it.
equals this over this, right?
So that's how.
Yeah, so and since the ratio of this SR over RD is 1, then CN over MB should also be 1.
Yeah.
So that means N is the midpoint of BC.
I got it.
Right? In this case, if you just randomly, well, this is when it's in the midpoint. Well, it doesn't matter if it's midpoint or anywhere. This is how you can prove that this is always true. So since this side is parallel to that side, so this triangle is similar to that triangle, right? So that this side over that side, I'll make that was A, this is B, this is C, this is D, right? And this thing here is E, and this longer one here is F, right? I hope this is kind of clear.
Yeah.
So this is E. So because of the similarity of these two triangles, we get A over B equals E over F. Right? And also because the similarity here, we get E over F equals C over D. Right? Well, this got connected, this is the bridge, so that we get A over B equals C over D, and then we can switch any two of these, right? You either switch these two or you switch these two. I switch B and C. So then we get A over C equals B over D, right? That gets proved. Right? So that is always true. Right? The ratio of this over that equals ratio of this over that. As long as these two lines are parallel. Right? And in this problem, there's one more thing that you want to get familiar with. So every time you see it, you automatically know it. It is true. So when you get a right triangle, this is a property of a right triangle. So that's a right triangle. Right.
Yes, the circle thing.
Yes. Or either you put a midpoint here, or you kind of do an isosceles triangle here, right? So you gotta be aware that this side, this side, this side are always equal when this is the midpoint of the hypotenuse. Right? So either you put a circle there, or you make a copy of this triangle and you flip over, you can fit it here. Okay? You can actually fit another exact same triangle here. Right? This is exact same. So that you get a rectangle. And,
That means on
well, if you extend that, you know, for a rectangle, the two diagonals bisect each other.
Yeah.
Right? So it's quite obvious in a rectangle that these four are all equal, right? But it's less obvious when this side is disappeared. This side disappears. And it's not as obvious as when the rectangle is complete. Right?